All right, we got a quick question. This is, I believe, in continuity, 1.5. This is related to problem number 5 in the homework. Number 5 in the homework has f of x equals 1 and -1. X does not equal 4, x equals 4. And then it has g of x equals 4x minus 10. And -6, again, with x doesn't equal 4 and x equals 4. Let's switch this up. Let's try, that's the homework one. Let's give you something that looks similar. F of x is going to look like, fuck it, 10 and -10. And we'll go with x doesn't equal 2 and x equals 2. And let's see, g of x. Let's see. 3x plus 2 when x doesn't equal 2, and when x equals 2, we're going to have -8. Zoom looks terrible right now on my screen. Is it blurry on yours?
Yeah, it's all blurry.
Let's give it a second. Let me switch cameras real quick, see if that helps. Nope, it's just Zoom. I hope it goes away.
Is that a 3x plus 2?
Yeah, that's 3x
Okay.
plus 2. In both situations, it's x equals 2 or x doesn't equal 2. That didn't help. Jesus, it's bad. There it goes, focused. I wonder if there's something on Zoom I can hit to make it focus. Okay, and then in the question it asks things like, is it continuous at x equals 4? And it gave examples like f of x, g of x, negative g of x, absolute value of f of x times g of x, g of f of x, and there's another one. But I think if we just go through a couple of them on this one, you'll get the premise of what's going on. Well, first off, is this continuous at f of x or g of x? So this is when x doesn't equal 2, this is just f of x equals 10, which is the equivalent of y equals 10. And this is y equals -10. So we have a graph. I'll set up a graph for both of them real quick. Y equals 10, except when x equals 2. I'll put a hole there. That's that graph. 3x plus 2 goes upwards as it goes to the right. It goes up to 4, 5, 6, 7, 8. It's got a hole there. Oh, it's got to go through 2. And then it equals -8 when x equals 2. So neither of those are continuous. Because this is, remember, we're doing limits in this chapter. So for it to be continuous, the limit has to exist going these directions, and it needs to equal the function evaluated at itself. Why is the brightness changing? There we go. So f of x is not continuous, g of x is not continuous. What about negative g of x? What is negative g of x? Negative g of x is negative 3x plus 2 when x does not equal 2. And it's positive 8 when x equals 2. If we stick in, do the limit as x is approaching 2, this is going to 3 times 2 is 6 plus 2 is 8. This is going to negative 8, and this one's it actually equals positive 8 at x equals 2. So this is just like the exact opposite line. It's going downwards. And it's got a hole right here, and it's actually solid up here. So negative g of x isn't continuous either. Is the absolute value of f of x continuous? The absolute value of f of x is the absolute value of each of these little each little part. 1 and negative 1. Of 10 and negative 10, sorry. This is when x does not equal 2, and this is when x equals 2. These both turn into 10. F of x equals 10. And it doesn't, if that's true for x equals 2 and x does not equal 2. That's just making a solid line up here. And so it's continuous for absolute value of f of x. Does that make sense?
Yeah, I could see how that's making sense.
Okay, a little bit more. Let's take a look at the f of x times g of x. This is one of the more complicated ones. So this is again a piecewise function. We've got 10 times 3x plus 2 when x doesn't equal 2. And we've got negative 10 times negative 8 when x equals 2. So we got to look at the limit as x approaches 2. F of x, g of x, or times g of x. And since 2, we can plug it in, it's a polynomial, we can just evaluate it there. This is 10 times 3 times 2 plus 2 is 10 times 8, which is 80. That's when x does not equal 2. When x does equal 2, f of x equals negative 10 times negative 8, which equals 80. So the product is continuous. Does that make sense?
Yeah.
And that's how you do this one.
Oh, okay. So I'm understanding how you're doing everything. The for the one part, how'd you get f of x equals 10 and negative 10? And then the 3x plus 2 and negative 8.
I made them up. You asked for a
Okay.
problem that was similar. I just made them up.
Okay. Oh, that's what it was then? Okay.
Yeah, I just made those up.
All right then. All right.
Okay.
Yeah,
So-
I got it now.
While I still have this video, it is important to note, I'm gonna just point it out as a reminder. Continuity. F of C has to be defined. F of x, limit as x approaches C of f of x has to equal f of C. That's one of our rules. B is this kind of, B goes together with A. F of C is defined. And C, this is where we have the limit has to exist. So they all kind of go together. We show this one exists by doing limit as x approaches C minus of f of x equals limit as x approaches C plus of f of x. That's how we show it exists. For a limit to exist, it does not need to do this one. So let's label them real quick. This one is required for a limit to exist. These two kind of make it continuous. Does that make sense?
Yeah.
Define, well, recall infinity is considered undefined. Infinity doesn't work. For these two going together. Well, all three of them going together. You're not going to get it where the limit all going. There's going to be a problem. If it's going to infinity, we've probably got a 0, and we've got, when we put c in for x, there's going to be a 0 in the denominator more likely. Or it's, it's going to be, there's going to be a 0 in the denominator, or it's going to 0 in the denominator, which means it's not defined there. F of c is not defined when the limit is infinity. So if we do the limit as x approaches c of f of x and we get infinity, this means f of x had something like x minus c in the bottom, which means it's not defined at x equals c. And thus f of c is not defined either. So if the limit's going to infinity, it doesn't work. It needs to be going to a constant. And the limits coming in from the sides have to equal the value if we plug it in. And that value cannot equal infinity. So B is kind of like saying not equal to infinity. That's really where f of c is, or f of x is undefined. All right, let me stop hitting record. That's a good recap for 1.5 and answer that question you had. Any other questions before I stop?
No, that was good. Thank you.